The Rover's frame is made of 2020 aluminium V-slot profiles. The frame can be easily unscrewed, reconfigured or expanded. The parts are 100% salvageable for future builds. It's one of the most affordable profile sizes, drastically lowering the initial cost for prototyping. In addition to the wide range of accessories for the profiles, various custom-made laser-cut aluminum parts are used. Laser cutting has become very affordable these days. The Rover is designed as a classic four-wheel drive vehicle. The planetary gear motors rotate at a maximum of 53 RPM and are equipped with encoders. The wheels are from Servo City and are called wasteland wheels. A tough plastic core is surrounded by a threaded rubber structure filled with airless, non-pneumatic tire cells that squish around uneven terrain without missing a beat. The airless tire is molded directly onto the wheel. Here you can already see a part of the Rocker-bogie suspension system. It was invented by NASA engineer Donald B. Bickler in 1988 for the use on the Mars rover Sojourner. To complete the Rocker-bogie system, additional laser-cut parts and hardware are required. I also designed the motor drive system, the battery management and the RC electronics to be modular. For the camera pan tilt unit I use bus servos. Unlike standard PWM servos that operate blindly in one direction, bus servos can send real-time data, such as position, load, voltage, current and temperature back to the controller. With 4096 steps per revolution, they ensure ultra-smooth and highly accurate movements. Instead of running a dedicated signal line from the controller to every single motor, bus servos allow you to connect multiple motors in a single chain using only 3 wires. And after months of construction, the Rover is finally ready for its first test drive on rough terrain.